Hey guys, this is Alok and I hope you all are doing very well. So today we are going to solve one more problem which is also from Geeks for Geeks, and it is the problem of the day. So today is 2nd January, and sorry for that, yesterday I was a bit busy, so I was not able to upload the video. So anyways, very happy new year to all. Let's start with the problem. So today's problem is that maximum value. Let's check what the problem is. So problem statement is bit like बहुत छोटा है. So given a binary tree, find the largest value in each level. So it is quite easy problem that I can see. So if you are familiar with that binary or like breadth first search or level order traversal, it is also gonna be like you can understand it is how easy. Okay, so tag medium, no worries, I will tell you in an easy way. So what you need to do, you just need to traverse binary, like traverse the tree as level wise and return the answer. Okay, let me tell you: 1 2 3 4 5 6 and 7. Let's suppose this is a tree. Okay, you need to return maximum of at every level. This is level 1, this is level 2, like both the elements in level 2, and this is the level 3. Okay, what you need to return? The maximum of at every level. Sorry, so what is the maximum at level 1? Obviously there is one element, so the maximum is gonna be 1. What is the maximum at level 2? 2 and 3. What is the maximum? 3. Okay, now 4 5 6 7. What is the maximum? 7. So our answer is going to be 137. Similarly, in let's check in this case, level 1 there should be 1, and level 2 and 3, which is like 2 and 3 at level 2 there is 3. So that's our answer similarly in this case. So let's try to solve it. So let me tell you the intuition behind how BFS or path first search works. So let's try to code in like pseudocode, or let me tell you, we are going to use a queue. Okay, in which we will use like we will install, initially there will be a root, only the one, initially one should be there. Okay, that we need to initialize. Now what you need to do, use one as you want. As there is only one element, then you need to use one as you want. Okay, let's take a temporary variable, temporary. So insert one here and pop from the queue. Okay, it is popped. Now what you need to do, you need to insert one's children, like there is left and right children in a binary tree. Check if there is left or right children present. If present, then you insert in the queue. Okay, let's check. One's right, one's left, 2 is there, then you insert. One's left is also there, sorry, right is also there, then you need to insert right 2. Okay, once left and right children are now in queue. Okay, so you traverse the first level, and now you are working on the second level. So this is the second level. Now you need to check at every level what's the size of the queue. Until that size you need to traverse, and this is the level. And when the size is going to like pass, then you need to, like, you will get to know that you are now at the next level. Okay, so how, like, in one is gonna use, so replace that temporary variable having 1 to 2. Okay, so now insert 2 in the temporary variable because 1 is completely used. Now we don't need any 1. Okay, so 2 is now inside in the temporary variable, and the size of the queue is 2. Now at the second level there is 2 elements, so this is a 2 element you need to insert. After that, like, one at the first level there was 1, at the second level there is 2 elements. Okay, 2 and 3. So do the same thing with the 2 and 3. So 2, how many children to have? Left and right, 2 children. So insert it in the tree, sorry, queue. So insert 4 and 5 inside the queue. Okay, we inserted 4 and 5, and now do whatever you want to do with the 2. Okay, so you need to get the maximum of this level now. So let's count maximum of each level in this. Maximum is goes to, like in this case, up till now maximum is 2. Okay, up till now maximum is 2 because 3 is not, we are not working on 3. So let's insert 3 here. Okay, because 2 is completely, like, we used completely 2. Okay, as 2's children are there, 2 is, we got it as maximum. Okay, now 3 is 3 maximum, then 2 because they are the same level. So yeah, update it. And now what you need to do, insert 3 child inside the queue. Okay, so 3 is having 2 child, 6 and 7, so insert them in the queue, 6 and 7 inserted. Okay, the task of 3 is already completed. Okay, now updated is 3 is also done. So now at the second level there is 3 is maximum. So at the first level there was 1, at the second level there was 3. Let's insert them any variable or any array or something na. Okay, so in next level, this is the third level we are going to traverse. So let's check about the 4. there is the maximum going to reset. Now maximum is start with the int main. Okay, so what we are going to do, let's check, is the 4 is maximum? Yeah, 4 is maximum till now. Okay, then insert in the maximum. Is 4 is having any children's? Is 4 having any children's? No, then we don't need to insert anything in the queue. Now check out the 5. Is 5 is maximum than 4? Yeah, 5 is maximum than 4. And then check for the 6, 7, and similarly until we are not going to get null. Okay, or queue is not gonna empty. Okay, so this is how we need to traverse, and this is how we need to get maximum at each level. This is how we need to insert the children's, and the algorithm is going to work. Let's try to code it. Let's try to code it. I hope you understood my intuition and approach. Now I'm going to code to tell you about the code. Okay, so as we need to return vector, create a vector. Vector of which type? Integer. Definitely it's going to be our answer. Okay, now need to create queue of node. Why we are creating the queue of node? Because we need to insert the elements of, or the nodes of the tree. Okay, so push queue dot push what node, or nodes only. This is the node. First node means the root element. Okay, now while queue is not gonna empty, queue dot empty. So let's check, is it working fine or not? It should work fine this time. Okay, yeah, it's working. Let's try to submit it. Okay, so was the code for, okay, yeah, that it got submitted. Congratulations. Was not too tough code, but yeah, it was quite easy to understand, quite believable to get. Okay, not like recursion, you can't think or imagine about that. So it is quite basic thing. Let me tell you again. You just need to create vector. For that you are going to return for answer of every level, create a queue, insert the node or the root inside the queue, and then take the size of the queue, like traverse the queue until it is not gonna end. Okay, or empty. What you need to do, get the size of the queue, and then create temporary answer so that you can get answer at every level. Okay, maximum at every level. Make it as minimum possible. Okay, so like check in that particular level, and means the size of the queue and the particular level the elements are over there. Okay, in the queue. So what you need to do, get the temporary, like get the top of that queue in a temporary node or temporary variable. Now you need to pop that from the queue because we are going to use it now. So check for the left, check for the right. If they're available, push them into the queue. So this is going to be add, like these elements are going to be add for the next level. So at this level what you need to do, check is it the maximum one, like whatever the value is temp at data, temporary node is having the value, is it the maximum? If it is, then keep that update in such a way. If it is maximum, then update, otherwise leave it. Now what you need to do, at the end of the loop means that end of the level, you need to insert the value inside the vector so that you can return the complete answer. So this is how at every level you are going to assign the value on